This is Algebra 2, Section 8.1, Day 1. Today we're going to start talking about exponential growth. So first of all, exponential growth functions look like y equals a times b to the x. And so when you look at that equation, the b value of that equation is what we call our base. So this b right here is the base. And this a value is actually, when you graph it, this is your y-intercept. And the fact that the base b is a number greater than 1, this is what makes it exponential growth. This is what makes your graph go up, because you're taking a number bigger than 1 and multiplying it times itself a certain number of times. Now, if you look at the graph here, this could be any exponential growth function here. I just want to point out that, there's an arrow on this end of the graph and there's an arrow on this end of the graph. So technically, this graph goes on forever to the left and it goes on forever to the right. Now, as it goes forever to the left, notice that it is getting closer and closer and closer to the x-axis, right? And as it grows, as we go, as x gets bigger on the right-hand side, the graph is going up. So the domain of our function is all reals, right? And we can easily see that because we can see that our x values, the graph lives everywhere along the x-axis. Those arrows mean it goes to infinity to the left and it goes to infinity to the right. However, the range of our function, our y values, are just greater than 0. As I said, the graph lives above the x-axis, so our range is y is greater than 0. The end behaviors of our function are, remember, what the graph is doing as x is either getting really small or as x is getting really large. So we would say that as x approaches negative infinity, f of x approaches 0, right? And that's what's happening. As our x values get small on the left side of our graph, that graph is approaching our x-axis, or the line y equals 0. This is called a horizontal asymptote of the function. And usually when I make a graph, I graph the horizontal asymptote with a highlighted line. So I would put a highlighted line right here. And this is my horizontal asymptote, which I call the HA. So I would say my HA for this graph is the equation y equals 0. And we're going to do this with every graph that you make, so this will make some more sense, right? But what we're talking about here is this idea that this asymptote is a line that a graph approaches but never crosses. And our exponential functions are always going to have horizontal asymptotes. And it's always going to be at y equals 0 unless you have a vertical shift. Then that's going to move your horizontal asymptote. So let's try an example. Because the domain of any exponential function is going to be all reals, we can plug in any x values that we want. But just to keep things simple, let's plug in x values that are easy for us, like -2, -1, 0, 1, 2. We have an extra space, so I'll do 3. So I'll do -2, -1, 0, 1, 2, and 3. And I am just plugging them into the equation for x. Now, if you have a calculator, you can certainly type these in on your calculator. So if you're going to do this on the calculator, you have to do that 2/3 in the front as 2 divided by 3 inside parentheses. So I'm going to write over here that on your calculator, you would do parenthesis, 2 divided by 3 parenthesis, and then you would do 2 caret, and then whatever your x value is, right? So whatever you're plugging in, that's what your exponent is. So I'll just put like a box there, because that's where you'd be plugging in your x values. So when x is -2, 2 to the -2 power actually makes a fraction, because remember, negative exponents, we would move the base down to the bottom. So 2 to the -2 would really be 1 over 2 squared, or 1/4. And then if you took 2/3 times that, you're going to end up with 1/6. So that's going to be our y value. When we plug in -1, 2 to the -1 power is 1/2. And then 2/3 times 1/2 is 1/3. When we plug in 0, anything to the 0 power is 1. So 2 to the 0 power is going to be 1, and then 1 times 2/3 is 2/3. When we plug in 1 for x, 2 to the first power is 2. 2 times 2/3 is 4/3, or 1 1/3 if you prefer. When we plug in 2, 2 squared is 4. 4 times 2/3 is 8/3, or that would be, 2 2/3. And then finally, when we plug in 3, 2 cubed is 8. 8 times 2/3 would be 16/3, or as a mixed number, that would be 5 1/3. All right, so now we're ready to graph these points. So I'm just going to plot the ordered pairs. Obviously, if they're fractions, they're a very tiny y value between 0 and 1, right? So when x is -2, y is 1/6. So that's going to be just a smidge above my x-axis. When x is -1, y is 1/3. That'll be just a little bit higher, a third of the way between 0 and 1. When x is 0, y is 2/3. Remember, we said that number in front, that a value was my y-intercept. There it is, 0 2/3. When x is 1, I'm at 1 1/3. When x is 2, I am at 2 2/3. And when x is 3, I am at 5 1/3. So you can see my points there have that characteristic exponential growth shape that we are used to seeing. Kind of looks like something that's hooking upward. So I'm going to go ahead and I'm going to connect my points here with a smooth curve. And I'm going to be sure to put arrows on both ends, because as we discussed, the domain is all x values, all reals. It lives everywhere. So what are my domain and my range? Well, I just said my domain is x equals all reals. My range, well, my graph only lives above the x-axis. So my range is y values greater than 0. Not greater than or equal to 0, because remember we discussed that we have that horizontal asymptote, and that horizontal asymptote is right here at y equals 0 on my x-axis. Okay, so my horizontal asymptote is that highlighted line that I just drew on the x-axis. In the equation of our horizontal asymptote is y equals 0. So our range is y values greater than 0, not equal to 0. All right, let's take a look at example 2. In example 2, I have y equals -2 times 2 to the x power. So notice that this time the a value in the front is -2. So this -2 right here, this flips the graph over the x-axis. So instead of it going up as our x values get bigger, it's going to plunge down. So it's like an x-axis reflection. My base here is 2. Just like it was in the last problem. And I'm going to choose the same x values that I did before as well, which were -2, -1, 0, 1, 2, and I like to throw in that 3. All right, so now again, you can do this on your calculator, but be careful. You're going to type it in as the negative sign. So on the calc, it's going to be the negative sign, not the minus, and then the 2, and then your times. And then it's going to be 2 caret, and then whatever you're plugging in for your x values. But I'm going to do it in my head. So when I plug in -2, exponents come first. So 2 to the -2 power, that's 1 over 2 squared, or 1/4, times -2. -2 times 1/4 gives me -1/2, or -0.5. When I plug in -1, 2 to the -1 power is 1/2. -2 times 1/2, that's -1. When I plug in x equals 0, 2 to the 0 power is 1. 1 times -2 is -2. When I plug in x equals 1, 2 to the first power is 2. 2 times -2 is -4. When I plug in x equals 2, 2 squared is 4. 4 times -2 is -8. And then finally, when I plug in 3, 2 cubed is 8. 8 times negative 2 is negative 16. That point's going to be off my graph. All right, so now I'm going to go ahead and plot these ordered pairs. When x is negative 2, y is negative 1/2. So again, now I'm below the x-axis. When x is negative 1, y is negative 1. When x is 0, y is negative 2. When x is 1, y is negative 4. When x is 2, y is negative 8. And then finally, when x is 3, I'd be at negative 16, which would be way down there. So now when I sketch my graph, again, I'm connecting my points here with a smooth line. And I'm staying below the x-axis because there's a horizontal asymptote there at y equals 0. So I'm going to draw that in with my highlighter as well, that horizontal line here. There's my horizontal asymptote. So now let's go ahead and talk about our domain and our range. Domain for exponential functions is always all reals. That does not change. Those arrows on the left side and the right side of the graph tell us that we can plug any x value in and we will always get an output. My range this time, notice that my graph is living below the x-axis. So this time my range is y is less than 0. And that is because my horizontal asymptote, which is right here, this is the equation y equals 0. But I'm below it, so my range is y is less than 0. Now, of course, exponential functions can also be shifted up and down, or they can be shifted left or right. So we're going to make these graphs just like we did last chapter, where we are going to graph our parent function first, which would just be up to the x in our equation, and then we're going to figure out what h and k are, and then we're just going to shift our points left, right, or up, down, depending on what our h values and our k values are. This works exactly the same as it did in the last chapter when we were manipulating our square root and our cube root graphs. So let's try our first example. We want to graph y equals 2 times 3 to the x minus 2 plus 1. And it says right underneath it, the easiest way to graph this function is to first graph y equals 2 times 3 to the x. We would call that much of the function our parent. Then shift the graph 2 units to the right because our h is positive 2 and 1 unit up because our k is positive 1. But we are going to start by making a table for y equals 2 times 3 to the x. Because that much up to the x, that is our parent graph. So again, I'm going to box that up here, okay? This much of the graph we call our parent, okay? Just up to the x. And that's always what we're making our table for. I'm going to choose my same x values that I always do, negative 2, negative 1, 0, 1, 2. I'll throw in that 3. Again, on my calculator, if I'm using a calculator to fill in my table, my y values are going to be 2 times 3 caret, and then whatever it is that you're plugging in for your exponent will go there. So for the first one, when x is negative 2, this time my base is 3, right? So it's going to be 3 to the negative 2 power, which is 1 over 3 squared, or 1/9, times 2 is 2/9. So that's pretty small. That's less than a third, because 3/9 would be 1/3. When x is negative 1, 3 to the negative 1 power is 1/3, times 2 is 2/3. When x is 0, 3 to the 0 power is 1. 1 times 2 is 2. When x is 1, 3 to the first power is 3. 3 times 2 is 6. When x is 2, 3 squared is 9. 9 times 2 is 18. That's pretty big already. And then when x is 3, 3 to the third power, or 3 cubed, is 27. And then 27 times 2, that's 54. That's not going to be graphable. All right, so now let's go ahead and let's plot our points. I'm going to switch back to black here for my parent graph. I've got negative 2, 2/9. So again, just just a hair above, it's not quite a third. And then -1 2/3. And then 0, 2, there's my y-intercept, that a value. And then 1, 6. And then 218 is too big for me to graph. Okay, so these points right here, these represent my parent graph. So if you want, go ahead and label that with a P for parent, just like we did in the last chapter. But now we're going to shift our points based on our H and our K. So up in the exponent, where we see that x minus 2 up there, remember, H is always opposite of what you see, and H is always going to be up in the exponent with x. I'm going to write that down. So if you don't see anything up in the exponent, that just means that H is 0. Okay, so H is up in the exponent, and our H value is +2, right? Because it's opposite of what we see, so we know that that means that we are going to be moving 2 units to the right. And then our K value is +1, and so we know that means that we're going to be moving 1 up. So now that's exactly what I'm going to do. I'm going to take each of my points, and I'm going to move them 2 units to the right and 1 unit up. All right, so 2 to the right, 1 up. 2 to the right, 1 up, 2 to the right, 1 up, 2 to the right, 1 up. All right, so here is my final graph. Sorry, I made that one a little thick maybe. I'll mark it F for final, okay? Now notice that my graph now lives above, more than just above the x-axis. Now it's living above y = 1, right? So my horizontal asymptote now has been moved to y = 1, and that is because of that k value that I had, right? So that k value is what moves my equation of my horizontal asymptote. So we'll make a little note about there. This moves my horizontal asymptote. So the equation of my horizontal asymptote for this graph is y = 1. My domain is still all reals. Always all reals for exponential functions. But my range is that my graph is living above that line, y = 1. So my range is y values are greater than 1. All right, in my last notes example, I want to make a graph for y = -2 to the x + 1 power -3. But again, when we make our table, we are making our table just for our parent function. And our parent function is just up to the x. Okay, so when I think about what that looks like, that's really y =. Now notice that the -2 is not in parentheses. That's kind of tricky. 2 is the base here, not -2. So it's really like my a value is -1 times 2 to the x power. Okay? Now I'm going to plug in my normal x values. Always choose -1, -2, -1, 0, 1, 2, 3 for your table. And remember, when you plug them in, you're doing your exponent first, and then you're multiplying times your a value or your y-intercept. So when x is -2, 2 to the -2 power is 1 over 2 squared, or 1/4, times the -1 is -1/4. When x is -1, 2 to the -1 power is 1 over 2, times the -1 is -1/2. When x is 0, 2 to the 0 power is 1. 1 times -1 is -1. When x is 1, 2 to the first power is 2. 2 times -1 is -2. When x is 2, 2 squared is 4. 4 times -1 is -4. And then when x is 3, 2 cubed is 8. 8 times -1 is -8. All right, I have my points for my parent graph, so I'm going to go ahead and plot those. When x is -2, y is -1/4. So again, this graph is going to live below the x-axis because my a value is negative. That's that. This right here, remember, makes me flip over the x-axis. All right, when x is -1, y is -1/2. When x is 0, y is -1. There's my y-intercept. My a value is -1. When x is 1, y is -2. When x is 2, y is -4. And when x is 3, y is -8. So there are the points for my parent graph. And so I will label this P for parent. But now I have to do my shifts. So I have to go back and look at my equation. And up in the exponent, I see x plus 1 up here in my orange parentheses. Remember, h is opposite of what you see. That means that h is -1. So a negative h value is going to move me to the left. And then my k value is -3, and that is going to move me down. So I'm going to take each of my points on my graph, my parent graph, and I'm going to move them 1 to the left and 3 down. 1 to the left, 3 down. All right, so here's a picture of my final graph. And notice that it's been moved down 3 units, which means that my horizontal asymptote has been moved down to y equals -3. So I'm going to go ahead and I'm going to add that highlighted line, that horizontal line, which is my horizontal asymptote at -3, right? So my equation of my horizontal asymptote is y equals -3 because that k value moves the horizontal asymptote. My domain, always x equals all reals. And the range of this graph, if you look at the picture, you can see that the orange graph is living completely below the horizontal line, y equals -3. So all of my y values are less than -3. That is my range for this graph. So this is it for the notes for section 8.1 day 1. So now please grab your 8.1 day 1 worksheet. You can see that you just have 4 graphs that you're going to make, and you are going to do the exact same thing on these 4 graphs that we've been doing in our notes today. So if we take a look at the first one here, we're going to graph y equals -3 times 2 to the x plus 1 plus 1. So we're going to start with making a table for our parent. And we know that our parent is just up to the x in the function. So we are making a table for -3 times 2 to the x. The x values that we are going to choose are going to be -2, -1, 0, 1, 2, 3. And that is going to be the case for every single graph you're going to do. So this is where I'm going to pause on this one, and I'm going to let you finish the parent table and graph, figure out your h and your k, make your final graph, make sure that you are putting in your horizontal asymptote on your graph and you're identifying the equation of that. It's always going to be, your horizontal asymptote is always going to be y equals whatever number it's at. Notice that the +1 over there is my k value, right? So that means that my horizontal asymptote is going to be at y equals 1 for this one. My h value, up in the exponent, I see x plus 1. That tells me my h value is -1, okay? So that's a little bit of help getting you started on problem number 1. And so now with the rest of the time, you can finish these 4 graphs for class tomorrow.